Hi, welcome back. So we are in section number 2 to discuss multiple inheritance. Some of the points we're going to discuss in this outline. First, we're going to be looking at the fundamentals and the conditions when it comes to multiple inheritance. And then we will be looking at a very, very famous problem called the diamond problem when it comes to multiple inheritance. And finally, a quick discussion when we have a different set of arguments. So let's go ahead and move to discuss what does it mean exactly with multiple inheritance. So I am back here to my Visual Studio Code, and we have worked on this simple class about the contact. And basically we have this class called contact, if you remember, and I have just made the change again to a basic list. And don't forget that we were able to actually create a class instead of using this list. The rest is remaining the same. I just add here one type of the contact to be a close friend, which happens to inherit everything from the contact. And that's why we use the actual word of contact here to initialize whatever from the init. And also the use of super method that we discussed in the previous video must be very clear, because it's going to be at help once we start talking about multiple inheritance. Now let's assume for a simple example, I would like to create something related to sending an email. Here the simplest and most useful form of multiple inheritance, actually it's called mixin. And mixin is generally a superclass that's not meant to exist on its own, but actually it's meant to be inherited by some other classes to provide extra functionality. Once again, let's take this example that we want to add functionality to our contact class that we just created here, and that allow this class to send an email to self.email. So sending an email is a common task, and we might want to use by some other classes as well. So instead of writing the function directly of email inside the contact, what I could do, actually I could go and create here a new class, and let's call it mail sender, something like that. And then we can maybe define a function called send mail, which take basically just self and the message that you want to send, something like that. And let's make a simple print function here. Now this class doesn't do anything special. In fact, it can barely function as a standalone class, but it does allow us to define a new class that describes both the contact and the mail sender. In other words to say, I could just completely create a brand new class, and let's call it, for example, email contact. And this is going to inherit everything from contact and everything from mail sender. This is now the function of called multiple inheritance. So if I would have to instantiate now a new object from this email contact, you will see it will request me with the name and the email, which actually happens to be from the contact class. What I could do, I could see now I can have access to the all contacts from contact. I could have access to the email and name variables, but I could have this to send email, which happens to be inherited from mail sender. If I would have to hit back to my terminal and run this, you can see now I am printing exactly as expected. Now what happened, we have alternative option of instead of doing actually multiple inheritance. In this case, we could have actually used a single inheritance and add this send email functionality to the subclass directly, mail contact, right? But the disadvantage here is that this email functionality then has to be duplicated for any other class need to be used. So it will not be really available to every other class rather than the use of this email contact. But we could have also created a standalone Python function, maybe just only responsible for sending email. But the best solution, in fact, and we're going to discuss this in details, is using what's called the composition instead of inheritance, which has a relationship, not is a relationship. We're going to be talking about in the future about this in details. But now in general, it is good that you have some idea about the multiple inheritance in principle. Now let's think of a new scenario. Imagine we would like to add an address to the friend or close friend, and we know address can be composite of number of variable, in fact, like the street and the city. In this case, maybe I would do something more interesting than just only adding these to the close friend. I just create a complete dedicated class. Let's call this class here address holder, something like that. because I could say now close friend is an address holder since it's going to be an inheritance. But if it's composition relation, I could directly write an address. And it's just like way of delivering this to other programmer who wants to carry on my code. So I could just define here maybe some initializer function with self to particular variable, like maybe street and city. And what we can move on, we could come to the close friend here, and we could actually make the inheritance also from the address holder. But that will lead me to a problem that's very popular when it comes to multiple inheritance. That's called the diamond problem. So let me show you in principle what does this diamond problem mean, as you can see in this picture. Imagine now I have this friend class, and basically it inherited from contact and it inherited from this address holder that I just created. This was going to happen for a friend, right? But don't forget that the contact and the address holder, both of them by default, we said they inherit from object. Remember that. So you could see now this would represent a kind of a diamond, and that's why we call it the diamond problem. Now question is that when I initialize friend here, he would come to maybe first, let's say from the left, and make the initialization of the contact by the name and the email. But the contact itself will go back to his own parents and initialize whatever from the object. And same from the right side here, you would come to the address holder, make the initializer of everything, but again the initializer will go to the same parent that just now the contact, and again initialize one more time. So this kind of variable in the object will be initialized twice. In fact, to illustrate this with a visual presentation on the problem, let me show you another graph here. If you look at this particular graph, it's mimicking the previous problem. So let's create this kind of subclass, and it has function called call me. And this subclass inheriting from right and left a class, whereby each one of them has its own function called call me. And both of them, of course, are inheriting from a base class. Let's also imagine that it has its own call me. Actually, I'm going to create this exact tree here inside Visual Studio Code and show you what that would look like. So here inside Visual Studio Code, I just created each one of these. So I have the base class, and then I have the left, and I have the right, and then you have the subclass. Inside the basic class, it has this local variable, and I set it to 0. And it has its own function called call me. It will print, and then it will add 1 to this local variable. So every time an object instantiated from the base class will add 1 to this particular counter. Same thing I did for the left class, whereby now the left is inheriting from the base class. Now in call me, I am using this base class to call me itself, because now this is done there init of the base class. And this, of course, I print this from the left class, and I add 1 to this counter. Same thing I did for the right class. Just inherit base, I set to 0, I open the call me function. Of course, I call the initializer on the base class since it's inherit from there, print, and then add 1 to its local variable. Now come to the last class, which is the subclass. Now the subclass is inheriting from left and right. So it will has its own, again, counter from subclass counter. Look at the names, I differentiate them clearly. And then it has its call me. Now here he is going to call from both parents, the left and the right. Look at the order here. And then it will has its own printing function. And of course, it's going to add 1 to this. Now let's instantiate an object from the subclass. Now subclass is instantiated and will have its own multiple inheritance from left and right. I am calling me the function. Let me show you up to this line here what the result would look like. Watch carefully what happens. So he first called me on the base class. So after I call me, he would come to this function, and then the first thing he is going to look for, he is going to start with the left subclass initializer. Now he will go to this particular class up here. Now I am in this class. Once I am in this class will go down and he will call his own base class. Now we go to the base class, and the base class basically just printing this particular function because it's called me, right? So he will calling me on the base class. That's why you have this first line. After he finish, he will get back to the left class and print this sentence on the left subclass. So calling method in the left subclass. Great. Now once it's done, this line, he will go now to the right. Now in the right, it will be following exactly the same. He will go to the base again, and he will print this one more time. So you could see now, I print base class twice, and then he will print right, and finally, after he finishes, he will print the subclass. This is actually happening behind the scene. And if you want to see the counters that we have seen here, how many times, you should actually make your own guess. You could see now we'll have 1, 1, 1, and 2. This is the problem that is known as the diamond problem. And that's why in the previous video, we have learned about something called the super class. If I make a small amendment on the way I wrote this code, you could see this problem that we have just encountered will not be exist anymore. So for my basic class, I will leave it just like as it is. Nothing is going to change. However, in my left class, when I come to this base class, instead of calling basic class, what I'm going to change this line to call the super function. So I'm going to call me. So you see this line here, it will make a huge difference, as you will see. Now the super class will just find his parent, or the next, actually, you understand in a while, and just instantiate this function called call me, and it will carry on. The same line, actually, I'm going to be doing it here instead of calling the base class. And the last but not least, instead of calling both here, this and this, I'm gonna just comment them and I put this line again. Believe me, if I would run this one more time, so exactly the result we wanted. So we have this contact, we have address holder, and we have close friend. So close friend here now will need to make inheritance from both the contact and the address holder. So what happens here is you can see multiple inheritance from the contact. I get these, from the address holder I get these, and also the close friend has its own particular variable. Now this will work, it's fine. I mean, you shouldn't have an issue at all, but this is really looks very messy and hard to control. Now the question is that how can we manage different set of argument when we're using this super class idea? We need to make some extra changes here. So if I could come back to the contact class itself, instead of writing name, I will just assume initial values, and I will add one more here, a new word called star kwargs. Now I will explain what does kwargs, but this is an industrial use by default, and of course you can use any other. I will discuss this in much more practical example, but for now just imagine it that way. I will explain by in a while what does that mean. I'll come to the address holder, same thing. I'll just assume both of them just like so, and then I would add kwargs. Now watch carefully for the close friend class that inherits from both. All what I have to do now, I will just write the phone with the default value and kwargs. And the next thing I'm going to do, I'm going to use now the super method that's powerful and we've been discussing. I will call the init, and inside here, I will call the kwargs. And of course, if I want, I could just go for self.phone. I will say equal to the phone that just passed here. Now, what does this kwarg do? It basically collects any keyword argument passed into the method that were not explicitly listed, like in our case here. I did not explicitly listed name or email, but since this kwarg, it happens to be in the contact and happens to be an address holder, and both of them are actually inherited by this close friend, the kwarg will go and unpack. So basically it will use a kind of a dictionary. Now if I would have to instantiate this object, for example, to pass here, say the phone, and just run again, email or any other arguments actually belong either to this particular inherited class or this. These arguments are added as we could go. And kwargs, actually the secret behind that. So kwargs is this kind of a dictionary. It's encapsulating any new variable and I add, which is not explicitly mentioned. You know, let me just print that kwarg itself to show you once I instantiate. Let's run this and see what the result would look like. Exactly as I said, this is a dictionary, so the kwargs. So I had the name and I got the email. Now, if I would have to add a new, for example, something completely, it's not either in the address or the close friend, maybe I would add something like called zip code. Now, if I run this one more time, you can see now X zip code is already added. But the question is that if I want to print it, I can, because CF does not have any access to something called a zip code, but it is inside the kwarg dictionary. If I would have one, they need to add this zip code, I would have to be able to do that. That was all about multiple inheritance. Next, we'll be looking at polymorphism. I will see you then.